This is problem number 4 from assessment number 1. In this problem it says, in 1990, the life expectancy of males in a certain country was 63.9 years. In 1995, it was 67.0 years. Let E represent the life expectancy in year T, and let T represent the number of years since 1990. Now, you'll notice I have this underlined here, because it says T is the number of years since 1990. That means 1990, in this case, is our baseline year, which means that we're going to use, instead of 1990, we're going to use 0 as the starting point, which means 1995 is the 5th year. Now, they want us to write an equation. It says find a linear function, e of t, that fits the data. So they want us to write a function. In order to write a function, we're going to probably use slope-intercept form. So we're going to say SIF is going to equal y equals mx plus b. But in our case, because they say let E represent the life expectancy, y is actually going to be the E of t. So E of t is going to be equal to mx plus b for this problem. So the first thing we want to do is we want to find the slope. So to find the slope, I'm going to write out the two coordinates. I've got 0, comma, 63.9, and then I've got 5 for 1995, comma, 67. So those are the two coordinates that I'm going to use to find the slope. I know m is equal to rise over run, which is equal to y2 minus y1 over x2 minus x1. That means that I'm going to end up with my y2, I'll label these y2, or x1, or x2, y2. This is x1 and y1. So this is 67 minus 63.9 over 5 minus 0. So 67 minus 63.9, that's 3.1 over 5. If I go ahead and use 3.1 over 5 and divide that, it gives me 0.62. Now I think in this problem they want you to round to the 10th. So I'm going to say that that is equal to 0.6 instead of 0.62. Now that's the slope. So I have the slope now. I need to find the y-intercept. So I'm going to use y equals, well, I'm going to use E of t equals 0.6 x plus b. I'm going to take one of these coordinates. I'll probably use 67 and 5, plug it in to find b. So that's 67 goes in for the, this is, remember, the life expectancy. So that's 67 years equals 0.6 times 5 plus b. 0.6 times 5 is 3. So I get 67 equals 0.6 times 5, which is 3, plus b. Subtract the 3, I get 64 is b. So my equation for the life expectancy is E of t equals 0.6, well, in our case, I was using x. They technically want us to use t here, so I'm going to switch the variable. I would say x, but they want us to use t. I should have used t right there. That was my bad. 0.6t plus the b, which is 64. So that is the equation for this, that models this, this function. So now what I want to do is I want to go ahead and use the function to predict the life expectancy of males in 2010. Well, 2010, how many years is that after 1990? Well, that's 20 years. So what they're asking me to do is they're asking me to find E of 20. Right? Because 20 years after 1990, that's what 2010 is. So I plug 20 into this function. That would be 0.6 times 20 plus 64. So I do 0.6 times 20 and I want to say plus 64. That gives me 76. So the life expectancy here is 76 for the year 2010.